Right, good morning, folks. I hope you're all well. 10 o'clock on a Wednesday has come around yet again, and we are going to be covering in this short little session an update on our carbon calculator. So, not quite sure how many people on the call were at our last one, but the long and the short of it is with RIBA 2030 being talked about more and more, not so long ago, maybe 6 months ago, I decided I would put together a tool to help design professionals and architects, specifically the design team, quickly be able to figure out the embodied carbon in your building designs. And so we quickly got from idea to our first kind of beta version, and now we're on version 3. And this session is talking you through the kind of the key points of the calculator, but also focusing on what we've updated. The calculator has got better. We've tried to keep it simple still to use so that anybody can use it who has a basic working knowledge of buildings. And we're really pleased with it. One of the biggest changes is a rebrand. Our company has gone through a rebrand, and so the calculator's been rebranded as well. But this is a free tool. At the end of this session, we will share with you the link for that. You can go to our website and download that link later on at the end of the hour. But for all of those of you who have signed up already and downloaded the calculator, by the end of the day, we'll have pushed out the version of that to you. So if you're new, you can sign up and get it. But if you're an existing person on that list, then we will send that to you to the email address that was registered by the end of today. So if you're really quickly, if you're new to Mesh Energy, I'm not going to go through slides like I normally do. This is a demo, so we'll demo it. But if you're new to Mesh Energy, a quick one on what we do. So we're independent holistic consultancy working with design practices, architects, and anybody who's involved in building design, be it commercial, be it residential, the whole shooting match. And we help to try and put some teeth behind the numbers, to do analysis, try and hold your hand or advise as far through the project as you want us to go. But increasingly helping design teams at the early stages really try and make low carbon buildings a success, and try and make it as easy as possible to deliver against more stringent energy targets. We're based in the south of the UK. We do projects across the UK, recently done one in the States and Europe. So we are getting further and further away from the UK, but we're based in the southeast. So the calculator, you can see here on screen, I've got the calculator shared, and I'm going to kind of walk through step by step some of the fundamentals, but also some of the quirky things that we've changed to really help out based on feedback that we've got and using the calculator ourselves to help improve things. So generally speaking, there is 3 tabs to this calculator. So this is the first tab. Hopefully you can see my mouse here. This is the first tab. This is really just an intro. Just, we start with a thank you, but go on to the kind of the main steps of how you complete the calculator. Really importantly, if you want to get more a bit in depth about it, we did do an hour-long user video, and I've done an update for this version 3 on some of the key highlights. And we've got these YouTube videos down here. What we will probably do is update the video that we're recording now as well and put that link on here. So this is just some initial information about the calculator, telling you about the kind of the colorization and stuff. A lot of this we'll get through, but if you're brand new to this or you hand this over to somebody else, this helps them out to start with. And the second tab that we've got here draws your attention to the fact that when we're calculating, when you're calculating embodied carbon, the way that the building performs from an operational energy point of view with respect to RIBA 2030 targets is being affected at the same time. And to help you guys along, to make sure you're getting the most accurate embodied carbon results, we've given a kind of a handy table here of typical U-value improvements that you're going to need to do domestically, but they're also very, very similar commercially as well. I'll talk about this because we bring this into the calculator as an automated function, but this is just a handy little table that shows you the kind of direction you need to be traveling. So you don't just get some quick, easy wins, think you've done it, and then get a shock when you look at operational efficiency as part of RIBA 2030. And this is the main calculator page. So we've got the opportunity in this calculator. I'm showing you one of the buildings here, but if you scroll to the right, you've got another design you can do and another design you can do. So actually, you can put in 3 different building designs here and play around with different variables and see how they compare. And you can change the building name here. The case study that we're just going to have this is based on actually is called Wayside, but you can type into this cell, this white cell, whatever reference name you want to. And generally speaking, white cells you can put information into. Blue cells are output cells, so they give you a result. And generally that's the rules of the game. We have put some notes in against these various cells, so you can have a look at those notes in the various cells just to help you along the way. But as we work down here, once you've named the project that you're working on, this is a fairly fundamental change of this calculator. Now you can look at domestic RIBA targets as well as commercial. So you pick between whichever one you're interested in. So in this case, we're looking at a domestic case study, but if you were to do a commercial one, you might have seen there, it changes this number here. So where my cursor is, the embodied carbon target threshold for that building type and the RIBA target that you're trying to meet, this is what you're trying to target as part of the calculator. And so commercial, you might want to target RIBA 2030. And it automatically changes. So you're trying to get down below 500. So rather than you looking up tables and trying to find what you're after, this immediately tells you. And in fact, to help you out even further, as you type in the numbers into the calculator, this cell here, this bottom one that says 493 at the moment, is a live output of the estimated embodied carbon for that development. So again, we've frozen this pane at the top. So as you scroll down, this is always in view. And hopefully that will prove useful. I mean, not having to scroll up and down the calculator all the time. You can immediately see the effect that a change is having, and you can play around with domestic and the various RIBA targets. So as we work down, again, for those who are new to the calculator, there's a really fine line to be had here between balancing, keeping this simple and getting some really meaningful data out of it. And I would remind you guys, this is suitable for kind of RIBA stage 1, RIBA stage 2 at a push. This is not a detailed calculator. It uses trusted figures from One Click LCA, which is a professional tool that's used for doing whole project embodied carbon analysis. But the level of detail that we're putting into this calculator is simply to give you design direction and to give you a far better handle on the type of materials and whether they're good or bad, and actually to give you a reasonable degree of accuracy, but not so much accuracy we get lost in cells and cells and tabs and tabs and tabs and it gets utterly unusable. So to keep this simple, we've got, if we look in this first column, we've got roofs and you've got sheet materials. A lot of this is based on sheet materials or layers, but for every element we have non-sheet materials. You may have struts or studs or something in that wall or floor or ceiling that is non-sheet material based, and we use a volume type calculation, so you can add these little bits in without making it an entire sheet unit. So the change for this calculator is we've got 2 different roof construction types. You're not just beholden to one roof construction type. You might have a flat roof that has a different construction to a pitch roof or, you know, whatever, but you can put in 2 different external roof types. We've got 2 different external wall types. We've got 2 different internal wall types. We've got doors, we've got windows, we've got the ground floor, we've got 2 different internal floor types as well. Sometimes that's necessary, and then kind of a miscellaneous at the bottom. So they're the logical external and internal elements of the building, but it catches that subtlety of having different construction methods. And to save time here, I've pre-populated some of this. But again, if you're new to the calculator, if you look in this materials column, you get to pick from about 45 different materials. And they are ordered, the materials at the top of this list are the lowest embodied carbon. And as you go down the list, they get heavier and heavier and heavier as far as embodied carbon is concerned. So funnily enough, you've got things like air at the top and sheep's wool insulation. And as you go down, you get into wood, gypsum, PIR, concrete, and then metals at the bottom. And so this, again, just having them in that order should help you figure out that the higher up the list that you are, the lower the embodied carbon. And when you put in materials, particularly sheet materials, you put in the material, you manually type in the thickness in meters, and you put in the surface area over which that covers. So in this particular case, the roof area on this building, it was pitch roof, 320 square meters. It was actually kind of SIPS type construction with clay roof tiles on top. So we've got our clay roof tiles and their thickness, our OSB board, its thickness, PIR, its thickness, etc., 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 and you work your way down to the plasterboard. In this particular case also, we had some non-sheet material. So we had battens in there, which were holding the tiles onto the roof. Now that's not a sheet element, but the battens themselves have a thickness, they have a width, and they have a pitch. So it auto calculates the volume of that timber. And once you type in the same area, it still covers the same roof area, you get an automatic embodied carbon value. And so when you put in the sheet materials here, it auto calculates the U value for that element, which again is very, very helpful. And you will see this particular U value is in green. Now, the reason that's green is again an auto indicator. I said to you before on this previous tab, this operational energy tab, that as you change your RIBA targets, your U values have to come down in order to keep operational energy under control. And as a result, you have to put in thicker insulation, et cetera, to get your U values to that point, and you increase your embodied carbon. But to make sure you're on the right kind of track here, what we've done, if I just change this PIR insulation value to 0.1, you've seen the cells turn blue again. And that's because we reckon the threshold for hitting the domestic RIBA 2020 target is around 0.18. So this is above 0.18 at the moment. So if you want to come in and say, maybe how thick do I need my PIR insulation to get there? It must be lower than 0.18. You can keep adding the PIR insulation values to see what the threshold is. So I think it must be about 0.13, 0.14. So we've got, yeah, 0.13. So as soon as this falls below 0.13, it goes green. And so you know, again, you're on the right track. So for each of these materials you pick, you get the embodied carbon contribution. And immediately, this is a great visual reference. And you can see instantly that PIR here at 8,700 kilograms of CO2 is way higher than plasterboard, is way higher than OSB board. And you can start to figure out whether there's another replacement that can have a lower embodied carbon. So this, rather than keeping it black box, it starts unpacking how those materials are contributing. And then we have an averaged value, which is for that entire element, which contributes to this number at the top. So this is saying the roof construction contributes about 64 kilograms of CO2 per meter squared. Now, to get values in these cells here, what is critically important in this calculator, if we scroll down, you'll see some yellow cells here, some bright yellow cells. And these are to do with the floor areas. So embodied carbon, the metric used is per square meter of floor area. So kilograms of CO2 per square meter floor area. As a result, you must have a floor area in this calculator to give you anything. If those are 0, it's going to give you an error or a divided by 0. So at a bare minimum, you must have a floor area in here. In this particular property, it was 200, and they had 80 square meters on the first floor. So make sure, and there is a note to remind you that you need to put those in the notes, but make sure at least one of these yellow cells is populated with your floor area to get meaningful data through the table. So that's the roof sorted out. We do the same things with walls. So you build up your walls. Again, we've got an indicator here that we're within the threshold for RIBA 2020 for the U value. We've got our wall area that we put in there. And again, you can see the massive contribution in this particular case for clay roof tiles. Now, one of the other big additions for this calculator is, because we're doing commercial as well as domestic, very quickly, obviously in commercial developments, you could get to multi-story developments. And again, to save you time here and to give you an idea, we've put in multipliers against walls, floors, et cetera, to help you duplicate that up without having to input the data over and over again on different stories. And this simply works. If you build up a single story of walls in this particular case, and this is a single story, but say you had a 10-story building, you can put in a multiplier here in this column A in this white cell that I'm looking at in A42. And as if by magic, everything gets multiplied by 10. Okay, and that obviously the walls become a much bigger contributor until you increase the floor area. Now, this is increasing the walls, but of course, if you increase the walls, you're going to have to go down and do the floors as well. So I'll show you that, but it is pretty obvious. So you've got these multipliers for walls, floors, and you've got internal walls as well. So maybe you have a particular layout of a particular floor, and that's being multiplied. You can multiply that as well. And down here for the floors, the ground floors you wouldn't multiply, there's only one ground floor, but the internal floors you can multiply up also to save you lots and lots and lots and lots of time. So nothing really changes here. You go through the walls, you build up your elements, you put in your miscellaneous kind of non-sheet materials into these parts, and nothing particularly kind of fancy happens there. It just builds and builds and builds your number, automatically builds your number up here at the top. So if we come down to doors, again, we've tried to keep this simple. I had people give us feedback on the first calculator and they said, oh, well, you know, you get loads and loads of different door types. Well, you do, but actually the contribution of doors is so minuscule, you mustn't get lost in some of that tiny detail. So doors here, we've got external doors and internal doors. External doors, this is a house, we've just got a couple of external doors, but you could change this, say had a double garage or some patio doors or whatever, you could change that to 4. But you can see here the fractional contribution, 0.3 is that compared to 490 for the entire property. So don't get lost in the detail of doors. Internal doors, again, we've just assumed a generic value for a pretty typical wooden internal door. This property had roughly about 10. And again, it's a fractional contribution. If you're doing multi-story buildings, you're going to have to multiply up these doors and same with the windows. So in this particular house, it was triple glazed. So you can pick, we haven't made this complicated, just double or triple glazing with wood and aluminium, nothing too fancy. And the total window area you can put in there. So again, if you had a multi-story building, you had hundreds and hundreds of square meters of double glazing, you put in hundreds and hundreds of square meters for this area here. And that's really about it. That's as complicated as doors and windows get. The floor, same thing again. Floors, you build up the floor elements, you put in the thicknesses, you put in the floor area, which you can do at this stage, or you can put in, maybe you'd start with this as a very first thing that you do with it in order to get some meaningful data as you work from the top down. Same with internal floors, you build these up in layers and you've got your floor area here. So you can see this is quite repetitive, pretty simple though, once you've got an idea of what you're doing. And at any point you can play around with, with messing around with these materials, or copy them over and try in another building and see how it compares. Now, hopefully that's pretty straightforward. You do things in layers and for those particular walls, floors, roofs, you might put in a material that has a particular material thickness, width or pitch. Same thing, we've got a general kind of miscellaneous area here, maybe for reinforcement or some other bits and bobs that are going in the structure. And we've got a much limited choice of materials here. Typically there'll be structural, so I've got wood, concrete, steel basically in there. But this allows you to pick up on some of those other things which are quite high contributors of embodied carbon and might be worth including. But you can either manually work out what the volume is, or as I say, put in the thickness, width, or pitch, which will give you the total volume of that material in the development. When we come down to things like foundations, you might have poured concrete, so you'd be looking at cubic meters of concrete, or I don't know, cubic meters of concrete blocks or something. Again, we've tried to keep this simple by saying, let's say we put in this particular building actually had a raft, but if you chose, let's say, recycled concrete, and you had a concrete mix, or say a couple of concrete mixer loads, you had 16 cube of concrete go in, you put in 16 into the footings, it tells you what your embodied carbon value is and its contribution. So you can put in or take out whatever's relevant. And that is really the fabric of the building done. Now, the other really key important point here, to meet the RIBA 2030 targets, or any variation of that, you also have to include the kind of the systems that go into the building. So generally speaking, renewable energy systems, the heating systems, the ventilation systems, the emitter systems, contribute about 25 to 30% of the embodied carbon value. So don't just think because you've put the fabric in that you're going to hit it. If you're just shy of it, the likelihood is once you put in the technology, you're going to be well over. So you must include technology as part of that to make sure you're giving yourself a fair answer. So we've broken this down into electricity generation, things like solar PV, heating and hot water, the emitter system, so radiators or underfloor heating, and ventilation. So with solar, we've left out wind, but we've put in solar. So if you put in solar, for example, in order to hit RIBA 2030, in most cases, you're going to need solar panels on the building. So you can either put in the amount of kilowatt peak that you're interested in, or you can put in the square area of solar panels that you've got available on your roof. So if you don't know the conversion, you can put in one or the other. Again, that tells you the embodied carbon. I mean, solar does add a surprising amount of embodied carbon, not least because these building embodied carbon values assume a 60-year life cycle. And so solar will be replaced at least once during that period. And so essentially you get a much higher embodied carbon value because it doesn't have a 60-year life. Now, the additions that we've made to the heating system for commercial, we've added CHP boilers in there, which would be gas CHP, but we've got gas in there, air source, ground source as well. Again, not hundreds and hundreds of choices. This covers off the bulk of the technologies that people will be looking at, and gives you a pretty good idea of the results if you pick any one of those. We've got underfloor heating and radiators. We haven't broken it down to, we're only going to have radiators on this level. You want underfloor heating on stories 2 and 3. In fact, actually, underfloor heating and radiators come out very, very similar per square meter. So really, given the stage that we're at, to give you an idea here, there's very little in it. So just pick one. But the fact that it's included will give you a more realistic idea. And then we've got mechanical ventilation or not. Now, increasingly, mechanical ventilation and heat recovery is being put into buildings. Not all buildings, but most. So you've got that choice also. Now, one of the subtleties that happens in the background here that, again, we've added to this calculator is as you try and hit more and more difficult RIBA targets, the insulation of the building elements improves and your heat loss reduces. So actually you need a smaller heating system. And we've picked that up, and I can show you that, which is happening in the background. So using our lookup table, we've got our U values changing. We've calculated a kind of a a rough and ready heat loss as a result of that in the background. But if I show you this, we've got RIBA 2020 at the moment for whatever size building, and you can see that the air source heat pump has a certain embodied carbon value here, 2156. And if I change to a more stringent RIBA target, you'll see 2156 change to 1540, so that's come down. If we change to RIBA 2030, it's fallen again to 924. You're not necessarily changing the emitter system, you're not necessarily changing the ventilation system, you're not necessarily changing the amount of solar that you're putting on the roof, but your heating system can get smaller, and that helps you bring your embodied carbon in because you can put in a smaller heating system on the development. So some of these subtleties we've started to bring in here to make this more realistic. And at the very bottom, we've got here a breakout of how the different parts of the building contribute to the overall development. And in this particular case, the technologies aren't quite as high as 25%, they're around the 15% mark, but it's still a meaningful contribution. So really, in a nutshell, that is the calculator and what it can do for you. It can be used for domestic and commercial. You can compare 3 different building types. You can call them whatever you want. You can play around to your heart's content, and you get immediate feedback on how your different material choices are comparing to the targets. I think for the moment, that's enough of an intro. I can see there's lots and lots of questions. I think this is a really good time to turn our attention to the questions and run through people's specific questions that they've got so we can answer those and make them more relevant. So let's just take a look at some of the questions here and see what we've got. So Rhiannon, is there any ones that you've picked up on here that are worth talking about first? Right, Rhiannon's gone. Okay, so somebody's saying, haven't downloaded the calculator yet. Yeah, that's fine. Yan Yang, if you get, there is a link which we will be putting up very, very, very shortly, if it hasn't been done so already, to our website. So if you go to our Mesh Energy website on the resources page, there's the EC calculator link, which Rhiannon will put up very, very shortly. Seb is asking, out of interest, do you have an idea of what safety margin for RIBA targets designers should be allowing for at stage 1 to allow for the inevitable uplift as projects go through the later design stages? That's a good question. No, no is the answer. I think, you know, more and more detailed design has to be done at those early stages, but pick a number. Whether you want to pick 10%, it's up to you. You know, there is a lot of thinking that goes on from stage 1 into the other stages, and it may be that you know, certainly if you're looking at steel work in a project, that's going to have quite a major effect on the embodied carbon. So you may want to go, you know, you may want more kind of detailed advice from your structural engineer as early as possible, so that value is as accurate as possible early on. Kate is asking, sorry, I missed the first few minutes. Where does the embodied carbon data come from? Is it generic or specific? How much material choice is there? Right, okay, so as I mentioned, Kate, at the beginning, this data comes from One Click LCA, which sources its data from environmental product data sets or database. There's thousands and thousands of third-party verified EPDs in there, and we've picked out 45 of the most common materials used. And we actually use that global warming potential data from professional one-click LCA software to give you the most accurate numbers possible, even at this early stage. As always, these calculators are only ever as good as the volumes that you're putting in and the construction types, but the data is verified data that would be used in a more professional calculation later on in the project. What about large areas of glazed doors? I guess you put them in as windows. Jana, yeah, that's absolutely correct. So glazed doors and windows are always a bit of a tricky one. What we've assumed here is doors. When you put doors in, they are solid doors, generally speaking. If you have big glazed areas, yeah, put them in as windows. You've got big sliding doors, or maybe a proportion of your window is more glass than solid material. Put it in as windows. That's probably the best thing to do to get you the most accurate answer. How do I handle adding a fabric build-up that's not homogeneous layers, e.g. timber frame? Right, so Kate, this is what I was talking about here. So if I give you an example, if we just go back to the calculator here, I can give you a really good idea here of how you would do this. So let's just go down and let's build up a timber wall. Let's say we do an external one. So let's just clear this out of this calculator here. Start from scratch again. Right, so let's say, for example, let's just pick an example here. Say we've got timber cladding on the outside of a building. Let's pick timber cladding. So we start with timber cladding on the outside. Let's just worry about the layers for the minute. So we've got timber cladding. We've probably got an air cavity in there. We've got battens. So battens, for example, would go in the non-sheet materials. So you would put in your battens. Now, the only slight issue by putting materials in the non-sheet materials section is your U value is just going to be slightly out. Your U value is calculated from the layers. So as soon as you start putting in non-sheet materials, then you get a slight variation on the U value. So once you've got your battens, then you're into, let's say, for example, I don't know, let's say there's a ply sheet on the outside. Wherever that is, or OSB. Let's say there's OSB on the outside. Then you have your stud wall with insulation infill. Let's just say, for example, we're using sheep's wool insulation as the infill. And then on the other side, you have your OSB board again. OSB, wherever that's gone. So OSB, and then say you've got battens on the inside of the building again. So let's put in another type of batten in here, battens, and then let's say there is, sorry, sheet material, let's put in plasterboard. Put in plasterboard. Right, so we've essentially got all our elements here. The one thing we haven't got is our joists. So let's put in joists here, which goes in between the sheep's wool. So you've got your sheep's wool in between joists in the middle. Let's put in joists. We've got softwood joists and rafters. So we've got all the fundamental building blocks here. The timber cladding, let's say that's 10 millimeters thick. The air cavity, doesn't matter how thick the air cavity is. Regardless of what number you put in the air cavity here, it won't affect the U value. So let's just leave that blank. The OSB board is 18 millimeters thick. 18, not 180. So if I kept my numbers right. Sheep's wool insulation, let's say it's, I don't know, 200 millimeters thick of sheep's wool insulation. We've got OSB board in there, which is 18 millimeters thick, and the plasterboard is 12.5 millimeters thick. So if we look at the battens, say the battens that we've got behind the timber cladding is, let's say that they are, so this is, when I talk about thickness here, I'm talking about depth. So let's say they're 25 millimeters deep or thick. Their width is 32 millimeters, and their pitch, let's say, for example, I don't know, they're on 150 millimeter pitch. This is the pitch of the battens on the outside. The battens on the inside, let's just say for argument's sake that they are the same as the outside. We'll just use the same numbers. So this may be, you may be creating a service void or whatever behind the plasterboard that you can run services up. Let's say we're on a similar kind of pitch. Now the studs that are going in between the sheep's wool, those are more traditional studs. So the thickness for those is 200 millimeters. We've set our sheep's wool, sorry, 200 meters there. Point two, our sheep's wool is 200 thick, so our joists are 200 thick. The width of those may be a couple of inches or 50 millimeters, and then the pitch of those may be 400. So we've got all of our elements in there. We've got our volumes accounted for because we've put in, for these non-elemental bits, we've got them in the pitch and thickness. and what have you. What you must remember though for non-sheet materials is you put in the area over which those cover. So let's say these cover the entire external wall. So everything's got that makeup. And you can see here, it's just broken out. You've got 600 odd for the studs. You've got 133 each for the battens. And it just builds it up element by element by element. So you can have sheet materials and non-homogeneous materials in there as well. Hopefully that's a long answer, Kate, but hopefully.
Yeah, can you hear me? Thanks, Doug.
No worries, no worries.
But the U value won't be correct, so that doesn't comply with how you calculate U value. For
it's a fractionally different U value. I mean, none of this is to replace using like a BRE calculator or a definitive U value, but it's going to get you pretty close. I mean, to be honest, a timber stud in a wall of that construction will have negligible impact on the U value. It might have a tiny effect, but yes, it does affect it. Okay, so that's the definition of that.
Cool, thanks for the demonstration.
No worries. And then Jana's asking again about limecrete. We haven't added limecrete for the foundations. And invariably, you know, there are materials that we're going to have left out here. More than happy to add materials to that, and we can get that out in the next version of this. So what I would say here is if you have materials that you think would be really, really, really useful, let us know. Send us an email, give us some feedback, put some comments on here, because it's feedback from you guys that's going to improve this and make this better. So do share that information with us. Okay, this is a really interesting one as well. So Jana's also asked about essentially sequestered carbon. Now, this is a big thing that's coming up because as part of BREEAM calculations, sequestered carbon is included in the calculations for carbon offset. And what we mean by sequestered carbon is things like trees and natural-based materials have absorbed CO2 through the lifetime of their growth. Funnily enough, an aerated concrete block doesn't sequester anything, a clay tile doesn't sequester anything, but trees and plant material does. And so you get a piece of data which is the embodied carbon without that lifetime sequestered carbon or carbon that's taken out of the atmosphere. And then you get data which does include that. Now, this data does not include that. And the reason it shouldn't be included, and I think it's a bit of a get out clause really, and I'm happy to discuss this, is that it gives you, particularly if you use a lot of timber in a building, it gives you a very, very, very easy get out clause. When you see the scale of the sequestered carbon figures against timber, it can offset a whole load of other big no-nos as far as construction materials go. So this is the kind of the toughest way to get there. And whilst RIBA 2030 is still kind of evolving as a standard, I would strongly suggest that you don't include sequestered carbon in your calculations. Some people will do, and some people as a result will get to net zero a lot quicker. But I would strongly suggest that you don't, and this data doesn't. So you get a genuine reflection on the embodied carbon.
Doug, sorry to interject. Can I ask a question on that?
Sure.
But if the data is coming from one-click LCA, and if they're using EPDs, are they just using the product stage for the EPD from the EPD? Because not all EPDs have all of the stages in there.
They will. Well, the EPD, the global warming potential value, which is being used for this data, there's lots and lots of numbers in the EPDs, but it's the global warming potential value that features.
Yeah, but the different stages of the EPD, you've got the product stage, which would include the sequestered carbon, and that's the only stage that's included as standard across all the EPDs. So I think that point you've just made about sequestered carbon, if I was looking at an EPD and I was only looking at stage A1 to A3, then that will include the sequestered carbon. And so if that's the number that one-click LCA are using, that's the number that'll be in your spreadsheet. I mean, these materials take into consideration the whole life, all of those stages. Yeah, but not all EPDs have all of those stages. I mean, I've done a lot of research into things like insulation materials, and they often don't include them. They'll just say module not declared. So
Right, okay.
It's a case of sometimes, which is really hard with different sources of data like this, is that they're not necessarily apples with apples. So sometimes you end up specifying a material and you think it's great, and actually it isn't great. It's just that they have put in an end of life stage that says we're going to recapture and recycle that. So we've created a circular process, but it's hugely impactful at the beginning, and that's what we're including in our building. It's just we assume that in 60 years' time, someone will shred it up and reuse it into new material.
Sure.
So I think that the majority of EPDs that I see only have the product stage in them, because that's the only stage that's mandatory. And if you're only looking at those EPDs, you will get the sequestered carbon at that stage. So it's just a case, I think it's where you've only picked 45 different EPDs to include, it would be really good to know, are they all of the life cycle stages, or are they just A1 to A3?
Yeah, to my knowledge, I mean, we run the software as a business, in its kind of most detailed form, and the data which has been taken against those materials do include all the product stages. To my knowledge, I will check that and confirm. It's obviously easier to do for a smaller selection, but I've got 12,000, then some of them are not going to have, not necessarily have all those stages. But I appreciate your comment on that, because it is worth thinking. None of us want to be giving out false data that's skewing the result, even at this very, very early stage. You're focusing on it.
Thank you. I've got a lot more questions, but I'll be quiet.
Right, thanks. So Niall has asked a question about, can elemental build-ups be imported from, say, Revit? Somebody asked me this question a few weeks ago, actually, and I did ask. I must admit, my knowledge of Revit is, I'm not a super user by any stretch of the imagination, but it would be quite cool if we could figure out a way of essentially extracting, whether it's a CSV file or something from Revit, to be able to pick up that and be able to run a macro and put that information into Excel. So more than happy to speak with people who use Revit on a regular basis to see what can work here and whether that's possible. I would make a gross assumption that 90+% of people on this call don't use Revit, but I appreciate commercially and for more difficult, complex buildings, it is used, and it is used as a standard. So more than happy to see how we can interact with some of those others and save you manually putting in individual components and possibly coming up with errors in here. What else have we got? Seb. Oh, we've got Niall, just come back to that. I think that's the bulk of the questions. So, as I say, no doubt there are loads and loads of questions about this. What I would strongly suggest you guys do is, as I say, we're going to be, if you haven't signed up for this already, go to the website, sign up for it, just your email address and not a lot else, and we'll send you a latest copy of it. If you've signed up for our previous versions, we'll get you this latest copy of it. I can't stress this enough. If you guys want to make a difference and you want to see a better calculator, give us some feedback. It's actually me that's coded it. It's not it's not a little pixie in the background. So me presenting this to you, I can immediately make changes and take into consideration the feedback. So if you give feedback, it will get back to me, and we can make this a really, really cool tool, and hopefully continue to make it free to really help you guys out the early stages. So use it, thrash it, give me your feedback, and let us know how it goes. But hopefully, by way of an update, that's given you a bit more of an idea of where the calculator's at, and who knows when the next version is going to come out. But hopefully not too far away, and we'll add some extra cool features in there without making it overly complicated. So for the moment, guys, as I say, I think that's probably a really good point to stop.